And welcome again. This time we are going to calculate the potential difference between center and corner of a square plate. This looks weird, but we can do it hopefully. So we have a problem that says two large square non-conducting plates, each of area S, are placed parallel to each other and separated by a small distance d. Electric charges plus q and minus q are distributed uniformly over their surfaces. Find the potential difference between the center and a corner of one of the plates. So this is the problem. We have plates like this. Like this. Yes. And we need to find out the potential difference. These are charged plus q on one or minus q on the other. And we need to find the potential difference between center and corner of one of the plates. So basic things first. We know that the magnitude of electric field between the center of the plates, not just the centers but almost everywhere, but not too close to the edges of the plates, is determined by E equals Q divided by epsilon naught S, that is sigma by epsilon naught. So the potential difference between the centers of each plate is going to be delta phi naught, and that will be equal to ED. And because D is the separation between the plates, and so you can get the result as QD divided by epsilon naught S. This is the potential difference basically, because this is the electric field. And we know that we actually don't know, but we need to prove it, that the field strength, that is the electric field, near a corner is 1 by 4 times that in the center. And how can we show that? So let's try. Suppose we have a capacitor like this, parallel plate capacitor like this. Now we are going to place three pairs of plates, similar plates, to our capacitor system, so as to place the corner of the main plate as the middle of the large capacitor. So you are going to put two plates like this here, and that is one pair of plates, and then you need to place two more superposing it. I can't show you here, but you can just place two more pairs, one pair for this pair and second for this pair, so that you will have altogether three similar plates, and you can place them like this. So you need to imagine something so that these two this becomes the center of the plate, the corner becomes the center of the large capacitor. And now we know that the field strength has been decreased by a factor of 4, because if you place this charge q and minus q to all this large capacitor, then the electric field will simply becomes q by epsilon naught 4s, because surface area has been increased by 4 times but not the charge, because we are going to provide them same charge, and so it will become electric field will become this, and so the potential difference between the plates potential difference between the center of this large capacitor becomes 1 by 4 that of delta phi naught, already calculated. So now let's move along a chosen closed circuit, like from the center of the first plate to its corner, and then to the similar corner on the other plate, that is from here to here, and then to its center, and then to the finally to the starting point, that is from here to here. So you need to move like this, and since the field is conservative, so total work performed by the electric field must be 0 in this case, because this is a closed path. So this is a closed circuit, and you can write here like we move from here from higher potential to lower potential, because potential at here is 1 by 4 times that of the potential at the center of the capacitor, center of the first capacitor. So the work done from moving a positive charge from here to here is simply positive, and also this is at higher potential than this, because both are negative potential, both are negative, and its numerical value is lesser and its numerical value is greater with a negative sign. So this is higher potential to lower potential. So again, in work done in moving a positive charge from here in this direction and from here to here in this direction must be positive, and it can be written as, suppose the charge is q, so you can write potential difference between these two are delta phi, and delta phi is the potential difference required. It is other than phi naught. We already know this is the potential difference required. So that is the potential difference between center to the corner of the capacitor plate. So I would like to write it as 2q delta phi, and then the potential difference from this corner to this corner is simply delta phi naught. It is this potential difference. This is at higher potential and this is at lower potential. And again, if you move from here to here, this potential difference is basically, this is higher and this is lower potential, and this potential difference is basically 1 by 4 delta phi naught, and this potential is lower and this potential is higher. So potential difference between this to this is minus delta phi naught simply. So you can write your results as work done in moving a positive charge from here to here is plus q 1 by 4 delta phi naught, and then here to here as minus q delta phi naught. and the total work done is equal to 0 as the field being conservative, and you can remove q, and you can find here that delta phi is equal to 3 by 8 of delta phi naught. Delta phi was what we are looking for, and delta phi naught we already have the value as qd by sigma naught epsilon naught, and put here, and you will get the result that it will be 3 qd by 8 epsilon naught at, and this is the answer. This is the potential difference between center and corner of a capacitor plate. Thank you very much for watching.